this episode, we move into a part of artificial intelligence, AI, governance that often feels abstract until something goes wrong: incident investigation. For a brand new learner, an AI incident is not limited to a dramatic breach or a public disaster. It can be any event where the system behaves in a harmful, unsafe, unreliable, misleading, or non-compliant way, especially when that behavior affects real people, real decisions, or real operations. Sometimes the incident is obvious right away, such as a system producing clearly harmful output or making repeated errors that disrupt a business process. Other times, it begins as a pattern of smaller signals that only make sense once a team looks at them together, which is why organizations need a disciplined investigation process and not just an informal hunch that something feels off. The most important idea to carry from the start is that AI incidents are rarely solved by one person staring at the model in isolation. They usually require a cross-functional team that can trace technical behavior, data conditions, human use, governance decisions, and operational context all at the same time. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good starting point is understanding what makes AI incident investigation different from ordinary software troubleshooting. Traditional software often fails in visible and direct ways, such as a crash, a timeout, or a broken feature that no longer behaves according to code. AI systems can fail more ambiguously because they may still be running, still answering, and still appearing useful while producing outputs that are subtly wrong, increasingly biased, less reliable, or poorly matched to the situation. That means the team investigating the problem is often dealing with uncertainty rather than a single broken switch. The output may be influenced by training choices, live data quality, changing user behavior, external inputs, unclear instructions, weak oversight, or unrealistic assumptions about what the system could safely handle. For beginners, this is a major mindset shift. An AI incident may not look like a machine that stopped working. It may look like a machine that keeps working just well enough to delay recognition that something serious is unfolding underneath the surface. That is exactly why cross-functional investigation matters so much. If only engineers study the issue, they may find technical symptoms but miss how business pressure, user misunderstanding, or policy gaps contributed to the incident. If only legal or compliance teams look at it, they may understand obligations but not see how data conditions or system behavior actually produce the event. If only frontline staff raise concerns, they may notice the harm but lack the visibility to explain the deeper mechanism. A strong investigation brings together the people who understand different parts of the system and the environment around it. That may include technical teams, security staff, privacy specialists, product leaders, legal counsel, compliance professionals, operations personnel, and the business owners responsible for the system's use. Beginners should notice that cross-functional does not mean everyone joins every discussion forever. It means the right perspectives are present early enough that the organization does not mistake a partial explanation for the whole truth. When an incident first appears, organizations usually begin with triage, which means deciding how serious the event may be and what immediate actions are needed before the full root cause is known. Triage matters because some incidents can continue causing harm while the team is still trying to understand them. A model that is drifting into unsafe behavior, producing discriminatory recommendations, or exposing sensitive information may need temporary restrictions, stronger review, or even immediate suspension in part or in full. At this stage, the team is not expected to know everything. What matters is recognizing that uncertainty itself can be risky when the system remains live. Beginners sometimes assume investigators should wait until they understand the exact cause before taking action, but responsible governance often requires the opposite. If the potential harm is serious enough, the organization may need to contain the situation first and complete the deeper analysis afterward. That is not panic. It is disciplined incident response shaped by the understanding that live AI systems can keep causing damage while people debate the details. One of the first things investigators need is evidence. and that evidence should come from more than one source. They may need production logs, output samples, user complaints, monitoring alerts, data pipeline records, change history, model version details, review notes, escalation records, and workflow observations from the people using the system every day. The goal is not simply to gather everything possible. The goal is to build a timeline and a behavioral picture of what changed, when it changed, who noticed first, and how the system interacted with the surrounding process. For a beginner, this step is important because AI incidents are often shaped by a chain of events rather than a single mistake. A data source may have shifted last week. A model update may have gone live 3 days later. Frontline staff may have changed how they relied on the outputs during a busy period, and complaints may have started only after those factors combined. Without evidence from across the environment, the investigation can become guesswork, and guesswork is a poor foundation for both accountability and remediation. A central concept in many AI incident investigations is drift. Drift refers to the way real-world conditions can move away from the environment the system was trained, tuned, or approved to handle. One form is data drift, where the type, format, pattern, or distribution of incoming information changes over time. Another form is concept drift, where the underlying relationship between inputs and outcomes changes, making earlier patterns less reliable even when the data still looks familiar on the surface. In practice, drift can happen because people change their behavior, business processes evolve, new products are introduced, language patterns shift, threat actors adapt, or external events alter the conditions under which the system operates. Beginners should understand that drift is not necessarily a sign of negligence. It is often a natural feature of live environments. The investigation challenge is determining whether drift contributed to the incident, whether the monitoring process should have caught it earlier, and whether the organization had realistic plans for adapting once the live environment began to move away from the model's original assumptions. Investigators tracing drift need to ask practical questions rather than vague ones. Did the input data reaching the system begin to differ in quality, structure, or subject matter from what the model previously handled well? Did important user groups begin interacting with the system in new ways that were not represented during evaluation? Did changes in the business environment alter what counts as a good output, even though the model itself was not updated? Did a change elsewhere in the workflow, such as a new intake form or new routing logic, quietly shift the conditions under which the AI system operated? These questions matter because drift is often distributed across the environment rather than sitting neatly inside the model. A beginner should see that an investigation is not just about asking whether the model changed. It is about asking whether the world around the model changed in a way that made its original evidence base weaker, less relevant, or more dangerous than decision-makers realized when they approved it for live use. Another common source of incidents is data gaps, and that phrase deserves careful attention because it can mean several different things. Sometimes the system is missing important categories of data, which leaves it unable to interpret situations accurately or fairly. Sometimes the data exists, but it is incomplete, poorly labeled, outdated, inconsistent, or not available at the moment the system needs it. In other cases, the data may be present in theory but filtered, delayed, corrupted, or disconnected by upstream process failures. A data gap can also appear when the team assumed that training or evaluation data represented the real world more fully than it actually did. For beginners, the main lesson is that AI incidents are often less about bad intent than about missing context. A system cannot reason well about signals it never receives, conditions it was never exposed to, or populations that were never meaningfully represented in the information shaping its behavior. Investigating data gaps means finding out where that missing context entered the chain and how it changed the system's outputs or downstream effects. Data gaps become especially important when the system appears confident despite lacking the information needed to support its conclusion. That is one reason AI incidents can be so misleading to inexperienced observers. People may see a fluent answer, a polished summary, or a decisive recommendation and assume the system had enough basis to produce it. A deeper investigation may show that critical details were absent, weakly represented, or never properly connected to the model at all. This can happen in customer support, hiring, fraud analysis, healthcare, education, and many other settings where incomplete information distorts the meaning of a case. A cross-functional team is valuable here because technical teams may identify the missing data pattern while operational teams explain how that gap arose in real workflow, and governance teams assess whether the organization should have recognized the limitation before deployment. Beginners should remember that missing data is not always obvious on the surface. It often reveals itself only when investigators compare expected system understanding with the thin or distorted reality of what the system was actually given to work with. Brittleness is another key idea in AI incident analysis, and it refers to a system that looks capable under normal or familiar conditions but breaks down quickly when it encounters variation, pressure, or edge cases. A brittle system may perform well in repeated situations close to its original design assumptions and then suddenly behave poorly when wording changes slightly, when an unusual case appears, when instructions conflict, or when multiple small stresses combine. Brittleness is dangerous because it creates an illusion of stability. Teams may trust the system based on many ordinary successes without realizing how narrow that success really is. When investigators examine brittleness, they are asking whether the incident exposed a fragility that was always there but had not been triggered often enough to attract notice. For beginners, this matters because a brittle system is not simply one that makes mistakes. It is one whose performance or safety may collapse rapidly once it steps outside a limited comfort zone, which makes ongoing assessment and realistic testing especially important in governance. Investigating brittleness often requires careful reconstruction of the conditions that produced the failure. The team may need to look at exact inputs, surrounding context, prompt patterns, interface behavior, user expectations, time pressure, fallback procedures, and any changes made shortly before the incident occurred. Sometimes the failure depends on a very specific combination of factors that no single team member would have noticed alone. A technical specialist may see model sensitivity. A product manager may recognize that users recently changed how they framed requests, and an operations lead may realize staff stopped performing a manual check because workloads increased. Taken separately, those details may seem ordinary. Together, they may explain why the system suddenly became unreliable in practice. Beginners should see this as one of the clearest reasons cross-functional investigation matters. Brittleness often emerges at the boundary where model behavior meets human workflow, and that boundary is easy to miss if the organization lets each team study only its own small piece of the story. Human factors also play a major role in many AI incidents, even when the system itself contributed technical weakness. Users may overtrust the system because it sounds confident, because it worked well recently, or because the organization positioned it as more capable than it really was. Reviewers may become fatigued and stop challenging outputs carefully. Managers may pressure staff to move faster, which can turn a decision support tool into a de facto decision maker. Training may be too thin, escalation paths may be unclear, or warning signals may be dismissed because nobody wants to slow the business down. A cross-functional investigation should therefore ask not only what the model did, but also how people interacted with it, what assumptions they were given, and what incentives shaped their behavior. For beginners, this is a crucial governance lesson. AI incidents are often socio-technical events, meaning the harm comes from the interaction of technology, people, process, and organizational pressure rather than from code or data alone. Once the investigation begins to identify root causes, the organization must translate findings into decisions and corrective action. Sometimes the right response is technical, such as changing a data pipeline, strengthening monitoring, revising model behavior, or narrowing system scope. Sometimes the right response is operational, such as improving review procedures, adjusting user training, clarifying escalation authority, or restoring human checks that had quietly weakened over time. In some cases, the organization may need to revisit its original governance assumptions and ask whether the system should have been approved for that use at all. Beginners should understand that incident investigation is not complete when the team can name the cause. It is complete only when the organization has acted on what it learned in a way that reduces recurrence and improves accountability. Good investigations produce decisions, not just explanations. They also produce records that show what happened, who was involved, what evidence was reviewed, what harms were identified, and why the chosen corrective steps were considered proportionate and necessary. A strong investigation also feeds back into broader governance, so the organization becomes harder to surprise next time. Findings about drift may improve thresholds, monitoring cadence, or update review. Findings about data gaps may reshape evaluation practices, intake processes, or deployment boundaries. Findings about brittleness may push teams to test more realistic edge cases, redesign fallback procedures, or limit reliance on the system in high-pressure settings. Lessons about human behavior may lead to better training, clearer communication, and more realistic expectations around oversight. For a beginner, this feedback loop is one of the most important ideas in the whole topic. Incident investigation is not only about solving today's problem. It is about converting a harmful event into organizational learning that strengthens release readiness, deployment governance, audit readiness, and post-release resilience across future systems as well. An organization that treats incidents only as local embarrassment misses much of their value and may repeat the same governance mistake under a different project name later. As we close, the most important point is that AI incident investigation is a disciplined search for truth across the full system, not a narrow attempt to blame a model or a single team. Cross-functional teams matter because drift, data gaps, brittleness, workflow pressure, governance choices, and human behavior often interact to produce the outcome, and no single function sees enough to explain the event alone. Tracing drift helps investigators understand how live conditions moved away from original assumptions. Studying data gaps reveals where missing or weak context shaped poor outputs or harmful decisions. Examining brittleness shows how a system that looked dependable under normal conditions may have been far more fragile than leaders realized. For a new learner, that combination is the foundation of mature AI governance after deployment. Responsible organizations investigate incidents not to prove perfection is possible, but to understand what really happened, reduce the chance of repetition, and make better, more defensible decisions the next time their systems face the complexity of the real world.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.